First we have radiation. What is this? First we have radiation. So what a radiation is? It does not require any medium for heat transfer. No medium is required for heat transfer. So heat is transferred from one body to another without actual contact or the movement in the medium. Now the second one is the ways of the transferring the heat. Example of this is heat transfer from the sun to the earth through space does not require any medium. The second is the insulation. So what an insulation is? Amount of the sun's energy received in the form of the radiation by the earth, that is the incoming solar radiation, so it is measured as the amount of the solar energy received per square centimeter per minute. So earth receives sun's radiation in the form of the short waves. Insulation are the short waves, and and the earth absorbs the short wave radiation during the daytime. Short waves absorbed by the earth in daytime and radiated back into space during night as long wave radiation. Third one is conduction. So the transfer of the heat through the conduction happens due to the molecular activity. Is because of molecular activity in a conducting medium. So there is no actual movement of the medium itself. No movement of medium itself. And the third one is the fourth one is the convection. Convection is nothing but the vertical rise, and advection is the horizontal rise. So convection, the transfer of the heat energy by the actual transfer of the matter or the substance from one place to another. Example is the heat transfer by convection cells in a boiling pot of water is an example of convection. And the fifth way of transfer of the heat is the heat from interior of earth. How it is? Some of the heat within the earth's interior is transferred to the surface through volcanoes, springs. They also transfer the heat. but this heat received as the surface is negligible as compared to the received from the sun, so it will does not affect much, will affect the distribution of the temperature. So let's now understand this point. Latitude. How latitude of a region affect the temperature distribution? So the intensity of the insolation depends on latitude. So the amount of the insolation is based on the inclination of the sun's ray, and which is more dependent on the latitude of a position at equator and at poles, how it is varying. So in case of the equator, the sun rays fall overhead directly throughout the year. Sun rays will fall directly vertically over the equator, and in case of the poles, the inclination of the sun's rays towards the pole is farthest from the equator increases, thus the air temperature drops from equator to the poles. That is the angle of the incidence is. So the area lying close to the equator receive the maximum amount of the heat due to the vertical rays. So here the amount of the insolation is more, and in case of the pole having the slanting rays, the sun's rays get progressively slanting as they move from the equator towards the pole. As the result, the heat is received from the sun decreases as the distance increases from the poles. So here the distance is increasing and the amount of the insolation will be less here. So the areas lying close to the poles receive least of the sun's energy as the sun's rays are near the horizontal. So here the sun rays will fall like the horizontal, and in case of the equator, the sun rays will fall vertical. In case of the equator, the sun rays falls vertical, and in poles, the sun rays will fall horizontal. So their insolation will be low. So this is how the latitude of a different place affect the temperature over the second factor is the altitude. How this is the altitude is varying. So atmosphere is indirectly heated by the terrestrial radiation that is radiating back from the earth surface to the space. So therefore, even at the same latitudes, the lower layer of the atmosphere is relatively warmer than the upper layer. For example, if we took the example of the Ambala and of the Ambala and the Shimla, latitude same, but still have the temperature differences. Why it is so? So the average temperature in Shimla is much lower than the Ambala. Shimla में temperature is low as compared to Ambala, and in Ambala temperature is high. Why it is so? It is because the Ambala plain is 272 meters. Ambala plain is 272 meters above the sea level. And in case of Shimla, it is 2202 meters above the sea level. So that is the temperature usually decreases with increase in the altitude. So the rate at which the temperature decreases with the height is known as the normal lapse rate. So this is the normal lapse rate. That is, with increase in the height, temperature will decrease. And how it is? This is 6.5 degrees Celsius per kilometer. So the mountains even in the equatorial region. So we took the example of the Mount Kilimanjaro in Africa of the equatorial region. But still it is snow capped. Because of the high sea level. Even because of the presence at the equatorial region, it will have low temperature. How it will help? Third is the distance from the sea. So in case of the coastal areas, during the daytime, sea breezes will form. And in the night time, land breezes will form. Now what is the land breeze and sea breeze? This is sea and this is land. This is land and this is sea. Land will heat and cold quickly. So during the daytime, temperature will be low at the sea and temperature in the land is more. Temperature is low and pressure will be high. Sorry. In the night time, land breezes will form. That is, during the night time there is the high pressure in the lands and low pressure in the sea, and in daytime they will form land breeze. During the daytime it will form the sea breezes. That is, in sea we have the high pressure and in land we have the low pressure, and wind will flow from high pressure to the low pressure. That is land breeze and that is sea breeze. We have already discussed the land breeze and the sea breeze. Now, so in the inland areas away from the sea have a harsh climate And the daily temperature range is low near the coastal and increase with the increasing the distance from the coast. So if we took the example of the Mumbai and Delhi near coast, near the sea, and Delhi is far away, that is inland. So in case of Mumbai, the maximum temperature and the minimum temperature in the summers experience is, Mumbai will experience the maximum 33 degrees Celsius and the minimum temperature experienced by the Mumbai is the 29 degrees Celsius. And in Delhi the maximum temperature experienced is the 50 degrees Celsius and minimum temperature, that is the 30 degrees Celsius. So the difference between the temperature is here the 4 degrees Celsius, and in case of Delhi there is 20 degrees Celsius temperature differences. So how it is? This is why, because of the Mumbai is near the sea. Mumbai is near sea, and so its climate is more influenced by the the climate of the Mumbai is more influenced by the sea. So this is the because of the distance from the sea. Though having the same altitude, Mumbai and Delhi still faces the temperature differences. Ocean currents. How ocean currents will affect? So the effect of the warm ocean currents and the cold ocean currents limited to the sides of the coastal areas. So ocean currents influence the temperature of the side by considering areas. For if we took the example of the UK, which is considered as a latitudinal location but still have a moderate climate, UK have a latitudinal location, but still UK have moderate climate. Why it is so? It is because of the ocean currents. How it will affect? So here we have Norway and here we have Berlin. Norway have 40 degree northern latitude and Berlin have 52nd degree northern latitude, but still have the same temperature. Why it is so? Because the warm North Atlantic drift current reaches to the Berlin. So from here there is a current, that is the North Atlantic drift current, and it is warm. It is a warm current which will reaches from the Norway to the Berlin. So it will make the temperature of the Norway and the Berlin having the equal. So the temperature at different latitudes can also be seen. And the last is the air masses. How air masses will affect the distribution of the temperature. So air mass is a large volume of the with the uniform temperature and the moisture. So the air mass can be having the two types of the air masses. One is the cold air mass and the second one is the cold air mass. Cold air mass and warm air mass. A cold air mass is that one is colder than the underlying surface, while the warm mass is the one that have the warmer underlying surface. So the cold air mass is the mass that is colder than underlying surface, and warm air mass is the air mass which is warmer than the underlying surface. So the area under the influence of the warm air masses experience higher temperature, and the area with the cold air masses will affect the experience of the lower temperature. So the warm air masses have high temperature, will have high temperature, and the areas having the cold air mass will have low temperature. So now when a parcel of the air mass, now consider we have a parcel of air mass. So there are some, and as we move from here, so this is a parcel of the air masses. So as when it and the surface of the earth is warm, then it will start rising, and this is the surface of the earth. Because of the incoming solar radiations, surface will get heated up, and this parcel of air masses will rise and also expand. They also expand. Further, it will also expand. And later on, it will further expand. Instead of further more expansion, it will expand up to a limit, that is the saturated limit of expansion. Then it will form the water vapors. Water vapors will form, and after that clouds will form. So as the parcel of the air mass moves upward, temperature will decrease. So the temperature of the area, of this area, is greater than the surrounding area. So if the temperature of this is T1 and the temperature of this is TA parcel, temperature of B, temperature of C, having the temperatures 2, temperature 3. So here the temperature T1 will be less than the temperature of the air mass. Similarly, the temperature in the second layer will be less than the temperature of B air mass, and the temperature will at the third level is also less than the temperature of the C air mass. And since we move upward, temperature will decrease with the height. So the temperature T1 will be more than the T2, will be more than the T3. That is temperature will decrease with increase in height. So without any external change in the heat, the temperature of the air parcel changes. It is because of the expansion and the contraction. So the rate of the change of the temperature is known as the adiabatic lapse rate. So this is adiabatic lapse rate. But it is without any change in external heat, temperature of air parcel changes. Why it is changing? Because of expansion and contraction. So the rate of change of temperature is adiabatic lapse rate. Now there are some other factors also which will also affect the distribution of the temperature, that is the nature of the region. Nature of region is also affect the distribution of the temperature. How? Tropical and subtropical desert desert, sandy surface, have high temperature because they absorb the solar insolation. And dense vegetation, that is example is Amazon forest. What will they prevent? Incoming solar radiation and but it will let the most of the sunlight does not reach to the ground. Sunlight does not reach to the ground. Similarly, the urban areas have the higher temperature than the surrounding, and dry soil will very sensitive to the temperature change, and the wet soil wet soil will heat slowly. Wet soil heat slowly. Why? Because of presence of the moisture of the January. If this is our earth, it have the tilt like this, and from the sun the incoming solar radiations are coming. So in the North Pole, no solar radiation. So the sun rays will overhead to Tropic of Capricorn, that is in northern hemisphere this is winter solstice, and in southern hemisphere it is summer solstice. So we know land is cool quickly and will warm quickly, and in case of the water it will take more time to cool and more time to warm up. So generally if we look, the temperature must have this is our equator. Generally it may be like this, that is having the 10 degree, having the 20 degree, sorry, having 0 degree, zero degree, 20 degree, have 10 degree. This is an equator, no? This is temperature. Above this there is 0 degree temperature, above it there is negative temperature, and so on. Here minus 10, here minus 20, here minus 30, something like that. Because of the land have quickly warm up and cools up, and see, takes more time to cool and to warm. So when the temperature is 20 degrees Celsius, let's, in case of the ocean, if there is a 20 degrees Celsius temperature here in the oceans, it will start increasing. Let's take an example of 10 degrees Celsius. In oceans we have 10 degrees Celsius. This is an example during the, in northern hemisphere it is winter solstice, and in case of the winter solstice the land will be more cold, will be quickly cold, and water will take time to cold. So when there is 20 degree when there is 20 degree Celsius temperature, 10 degree Celsius temperature in the oceanic surface, since the land has taken is more quickly be cold and more quickly will in case of the winter solstice the land will be more cold, the temperature will start falling, and in case of the ocean the temperature is relatively more than the land, the temperature will start rising, and again in the case of the land masses it will get trap the heat quickly, that is the temperature will again rise. So this, and similarly when there is 0 degree Celsius temperature, so ocean will get will hold the will be cold. So when there is 0 degree temperature in the oceans, we have approximate minus when there is 0 degree temperature in the oceans, we have approximate 5 degree temperature on the land, and when there is minus 12 degree Celsius temperature on the land, oceans have approximate 0 degree temperature. So we see in winters the groundwater is seems to be like warmer, but it is not warmer, it is relatively warmer than the land, because water will take more time to get cold. Similarly here, the land will be first get cooled, so there is 0 degree temperature Celsius, and when the water get cools, it will take more time to release the heat. So instead of having the temperature 5 degrees Celsius in the oceans, it will have minus 25 degrees Celsius, is around the minus 25 degrees Celsius temperature, because of it will get warm because of taking the time taken by the oceans to become warm will be more. So it will have the more temperature, will have the more less temperature, because it will take more time to cool, to become warm, and the land will warm quickly. So this is the temperature differences in case of the January. Similarly, in case of July, in case of the January month, so in the southern hemisphere there is no much differences, because of the most of the land is most of the area is covered by the oceans, and there is a little portion is covered by the land, so there is not much so differences. Now in case of month of the July, in the southern hemisphere we have winter solstice, and in the northern hemisphere we have summer solstice. So land will get quickly hot and water will take time. So when there is 10 degree Celsius temperature of the ocean, the temperature at the earth is much more, is very less, sorry, because of the when the oceans have the 10 degree temperature, in oceans we have 10 degree temperature, the land masses have approximate 5 degree temperature. Have more temperature, huh? If there is 20 degree temperature in the oceans, in oceans we have the 20 degree Celsius temperature, and in lands we have approximate 30 degree Celsius temperature. Why it is so different? Because earth will be get more quickly hot as compared to the ocean. So when there is the temperature in the ocean is 20 degrees Celsius felt, in the land the temperature felt is the 30 degrees Celsius. So this is because of this reason, because of the specific heat of the earth is very low and the specific heat of the water is very high. So the difference in the pressure belts is because of the specific heat of the water and the land surfaces. This is the range of the July and January collectively. So the effect of the ocean is well pronounced in the southern hemisphere. Here the isotherms are more or less parallel to the latitude variation, because of there is no presence of the much more land masses, and because of the presence of the more ocean, that is the one type of the surface, so it will have the more similarities in the temperature distribution. In case of the July, the isotherm generally runs parallel to the latitudes. The equatorial oceans receive the warmer temperature more than the 27 degree over the land, and 30 degrees noticed in the subtropical continent in the Asia and this. So this is the main difference. Because of the presence of the difference in the temperature distribution, it will happening. So we have to just calculate. Similarly, in the case of the month of the January, if there is now see, this is in 0 degree belt. So here we have almost 10 degrees Celsius temperature, and in oceans we have 0 degree. In oceans we have approximate 0 degree, then we have the temperature on the land is 10 degrees Celsius. So land will be cold quickly. Land will get cooled quickly. So if there is 10 degree temperature in the ocean we have 0 degree temperature in the land surface. That is the difference in the temperature. And if there is minus 12.5 degree Celsius temperature on the land, minus 12.5 degree Celsius on the land, then in this case in the oceans we have, that is 0 degree. Oceans we have 0 degree, and this is because towards the North Pole having the extreme conditions, but still in the Atlantic Ocean, this is the Atlantic Ocean, there is maximum 0 temperature, 0 degree temperature is maximum, but still the landforms here I have minus 20.5 degree Celsius temperature, and oceans will have 0 degree. Oceans will have 0 degree Celsius temperature, and the land surface will have minus 25 degree Celsius temperature. This is all because of the warm and cold currents. And one more factor in this chapter is the temperature inversion. So basically with the increase in the height, temperature will start decreasing, but in some, generally it will happen, but in some cases the temperature will start with height, it will start rising. So this is known as the temperature inversion. So there are some different type of the temperature inversions. The temperature may sometime rise with the temperature sometime rise with the height instead of decreasing. So the increase in the temperature with height is known as the temperature inversion. It is temperature inversion. What it is? With increase in height, temperature also increases. Generally, with increase in height, temperature decreases. So if with increasing the height, temperature start increasing, this is known as the temperature inversion. There are different type of the temperature inversion, and they will form. First one is the surface inversion, valley inversion are some example of the temperature inversion. So in case of valley, this is the mountains, this is the valley, and this is the mountain. So here we have the cold air, as the temperature will decrease, and here we have hot air. Hot air will start rising, and the cold air will start sinking. So this cold air, which is coming this and this direction, will uplift the warmer air and cool it. That is condense the moisture, condense out the moisture. So it will lead to the formation of the fog. And it will add, that is the night time cooling. How this fog is formed? Now we know in winters the outgoing terrestrial radiations are more than the insolation. So the land becomes colder. Then the air abodes. Land will cool fast and it will release all the outgoing terrestrial radiations. So when the land cools, the air when the land cools, air condenses. So there will be a condensation. It will uplift the hot air, that is the uplifting of the cold air, upliftment of the warm air by the cold air. It will lead to the formation of fog. This is the temperature inversion.